Hi, so this video is going to show you how to predict the pH of a salt. So the way you will think about this and memorize it is that strong acid make weak conjugated base, weak acid make strong conjugated base. Okay, so how does that do with the pH? So a way of thinking about it, and it's not completely true, but it's an easy way to imagine it. So think of it in terms of a pH scale. The pH scale go from pH of 0 to 14, with 7 in the middle is a neutral pH, right? So let's consider a strong acid. So let's say a strong acid, HCl, that's going to completely dissociate into H plus and Cl minus. So HCl here is the strong acid, Cl minus. This is a Cl minus is a conjugated base. And this conjugated base is going to be so weak that it's going to be neutral. So again, a way to think about it, let's take, so HCl is a strong acid. Let's say 1 mole of HCl is going to have a pH of 0. Its conjugated base is going to have about 7 pH higher. So Cl minus is going to have a pH of 7, neutral. Alright, let's try something else. A weak acid. Let's take an example of a weak acid, CH3COOH. This weak acid is going to partially dissociate into H plus and COO minus. So CH3COO minus, this is the strong conjugated base. So let's say CH3COOH has a pH of 3 here. Then its conjugated base going to shift about 7 points over here. 3 plus 7 is 10. So CH3COOH, a strong conjugated base, is going to be basic, pH of about 10. Alright, let's try one more. Let's say something like NH3 ammonia. Alright, ammonia is a weak base. It's not an acid, it doesn't give out H plus, it's accepting H plus. So it can accept an H plus and form ammonium. Since ammonia is a weak base, it's going to form a strong conjugated acid. So let's say an ammonia having a pH of 11, 3 pH 7, 11. Its conjugated acid is going to be 7 points less than 11. So 11 minus 7 is 4. So I would guess that its conjugated acid of the same concentration would be having a pH of 4. So I would guess NH4 plus is having pH of 4. So although this is not entirely true, because again, pH depending on the concentration, it's just some way, it's an easy way to think about it. So when do we use this? When do we apply this? You apply this you can apply this in predicting what is your equilibrium points, equivalence points going to be, or what is your resulting salt solution from a neutralization reaction going to have the pH of. So example, if I have the x-axis here is the volume titration and the y-axis is my pH, and let's say I'm titrating the weak acid with a strong base. Well, I'm going to start out with a pH of, let's say, around 3, and I'm going to end up with excess NaOH. So the NaOH is going to be 13 or 14. Let's say 14. So my end point is going to be way up here. My starting point going to be around 3. Now at the equilibrium points, the middle here, what I have is Na and CH3COO. I'm going to have the salt Na. Now CH3COO, as we talked about earlier, is a strong conjugated base. So it's going to have a pH of around 10 there. While Na, that's the result of NaOH, which is a strong base. So Na being the conjugate acid is going to be pretty weak. So it's going to be neutral, it's around 7. So that doesn't play into the pH of the whole thing. So your equivalence point is going to be around 10 according to this schematic. So then you will draw a line of going up and that. So this predicting a pH of the salts have useful application as such.